In lesson 8, we're going to look at how to solve systems of polynomial equations algebraically. So what that means is we're going to be given two equations of polynomials, and we're going to take one equation and we're going to substitute it in for the other. Now the easiest way to do this is going to be to get one equation equal to y and then plug it into the second equation. So if you look at this first example, I know that I have a quadratic equation and I have a linear equation because here I have an exponent of 2 and here I have an exponent of 1. So what I'm going to do is get one equation equal to y and then plug it into the other equation. And if you look, this first equation here is already set equal to y. So what I'm going to do is I'm going to take that and I'm going to plug it into the second equation. And before we do that, we just have to fix this. This should say -2, so just make that change. And then what we're going to do is we're going to rewrite that second equation. So it's going to be 2x minus, and instead of y, I'm going to replace it with what y is equal to, which in this case is x squared plus 2. Notice that I'm putting it in parentheses because I'm going to have to make sure I distribute that negative. So I'm replacing x squared plus 2 in for y. And then that equals -2. And then we're going to go ahead, now that I have one equation and one variable, I can go ahead and solve this. So we're going to distribute this negative through. So we have 2x minus x squared minus 2 equals -2. And since I have an x squared involved, that means I'm going to have to factor. So whenever we factor, we have to get 0 on one side. So bring the 2 over. So these 2's end up actually canceling. So we have 2x minus x squared equals 0. And typically we like to get that x squared term in front. However, in this case, since I don't have a plus or minus number or no constant at the end, you can really just think of this as GCF factoring. So it doesn't really matter if that x squared is not in front. It's not going to make a difference. But if you were doing quadratic formula or quadratic factoring, where you would have to figure out what adds to the middle term multiplies to the last term, that's when you want to make sure that x squared is in front. So I'm going to go ahead and just leave it, and I'm going to take out a GCF, so I have 2 minus x left. Now that I have multiplication between these two terms, I know that x has to equal 0 or 2 minus x has to equal 0 in order for the product to equal 0, so I just split them. So then I just have to solve this, so add the x over, so we get 2 equals x. So these are my two x values where my two equations would cross on a graph, or these are the two x values that they have in common. So now what we have to do is we have to find the y value. So now that we know the x values, we need to find the y values that correspond to these x values. So basically, when x equals 0, I have to figure out y. So I'm going to take and I'm going to go up to either one of the equations. It'll be easiest to use the first equation, but really you could use either of them. And I'm going to plug into my equation. So let me just copy it down. Y equals x squared plus 2. So y equals, plugging in 0, we get 2. So one of our solutions is the ordered pair 0, 2, and you do need to write these as solutions because if I plug in 0, you need to know what y value corresponds to that. So 0, 2 is one of them. And then the other one is when we plug in 2 for x. So again, plugging that into my first equation, it doesn't matter which one, I just chose the first one. You get out 6. So the other solution is 2, 6. So here are your two solutions. And again, to check these, what you would do is you would take both of those solutions and you would plug them into both equations. Another way to check is to do them graphically. And if you remember in the previous lesson, these are actually the two solutions that we got because we started with the same two equations. So one last example here that we're going to do is just another type where we're going to be solving looking for the solutions in common. Just make sure that whenever you do these, you do write your solutions in ordered pairs or as coordinates, because you do have to make sure that you say, well, x equals 0. I can't just say, well, y equals 2 and y equals 6, because it matters. When I plug in 0, the y value is going to change. So when I plug in 0, the y value get out is 2. When I plug in 2, the y value get out is 6. So the solution is the coordinate or ordered pair 0, 2 and 2, 6. So let's look at one more example of solving a system algebraically. And for this example, I have two quadratic equations, but remember, it doesn't really matter the type of polynomial you have. It's going to be the same process. So you're going to get one equation equal to y. So in this case, they're both equal to y. And then I take that equation and I plug it in for y in the second equation. So basically, I'm going to just set these two equations equal to each other. So we have the first equation equal to the second equation. So since they both equal y, I'm really just setting them equal to each other, or you can think of it as substituting the first equation into the second equation. And again, I have an x squared involved, so that means you got to get 0 on one side. So the first thing I'm going to do is get 0 on the right-hand side. So all of these are going to cancel, so I get 0 over here. And then on the left-hand side, I have 4x squared plus 8x minus 5. And now you just need to solve this for x. So there's a couple ways you can do it. You could use quadratic formula, or you could factor. And I'm going to go ahead and factor. So what I'm going to do is I'm going to do that AC slide method, which will create factor by grouping. So I multiply these. So we need to multiply to negative 20. And we need to add to the middle term, which is 8. So the two numbers that are going to multiply to negative 20 but add to 8 are going to be 10 and negative 2. So what that means is I'm going to take and I'm going to rewrite 8 using those. So if you look at how these numbers on the outside work, I have 4 and negative 5. So I'm going to have to group my 10 with the 5. So what I'm going to do is I'm going to rewrite that negative, or that positive 8x as negative 2x plus 10x. So if you look, if I were to combine those, I would get 8x. So I'm keeping the x's because I need to get back to that 8. And then from there, I'm just going to carry everything else down. So I have 4x squared minus 5 equals 0. And now you can split this and factor out a GCF out of these. So we have a 2x that we can factor out. So I'm left with 2x minus 1. And then here I can factor out a 5. So I would have a 2x minus 1. And now you factor out this part. So we have 2x minus 1 that I'm factoring out of this first piece. So I'd be left with a 2x. Factor out a 2x minus 1 in this piece, I'd be left with a plus 5. Now that you have two things being multiplied to equal 0, you can set each piece equal to 0. And solve each of these. So we get x equals 1/2. Bring the 5 over on this one. Divide both sides by 2. We get x equals negative 5/2. So here are my two x values, but now remember, we have to find the y values. So the last step here is to find the y values. And we're going to use either one of our equations. So I'm going to use the second equation just because the numbers are smaller. So to me, it's a little bit easier to do the calculations, but it doesn't really matter. So you have to figure out the y values. So I have when x equals 1/2, I'm going to plug in, and when x equals negative 5/2. So we're going to plug in to our equation. So 2 in parentheses 1/2 squared minus 1/2 plus 1. And when you simplify that, you'll get 1. So that tells me that one of my solutions is going to be 1/2 comma 1. Again, we write it as an ordered pair because the 1/2 and the 1 correspond to each other. And then we're going to do the same thing with this -5/2. Make sure it's a minus and then another minus. So when you evaluate this, you get 16. So again, written as a solution, -5/2 comma 16 as an ordered pair. And if you wanted to check your work, you could graph these two parabolas and see where they cross. Or you could take both of these solutions and plug them into the original equations. They have to work in both equations. That's what it means for a system. So you'd have to take these and plug them into both equations, and then take these and plug them into both equations. So it would be 4 separate things that you would have to do. But it would be a good way to just check to make sure that you did get the right solutions.